Lights go down and I hear you calling to me, yeah. Right now, I wish you were here with me. 'Cause right now, everything is new to me. Hey guys, and welcome back to Right Now. This is the last section of Unit 8. We are just rolling right on through. So let's get started. So 8.5 is about special right triangles. And this is a really important section because we use these special right triangles a lot in trigonometry. In our next section, our next unit is trigonometry. And so here we go. Our two objectives are one, that I can state the ratio of sides and angles for the special right triangles, and B, I can use special right triangles to solve problems. All right, so let's get started. Let's say we have a square ABCD that has a side length of 1. So let's find A in simplest radical form. So it would be 1 squared plus 1 squared equals C squared. So this would be 2, the square root of 2. Now let's do this one. So this would be 2 squared plus 2 squared equals C squared. And 2 squared is 4. All right, let's do this. So we get 2 squared plus 2 squared equals C squared. So this is 8. So 8 equals C squared. So that means this is the square root of 8, or 2 radical 4. Oops, sorry, 2 radical 2. So we get 2, we get 2 and 2 radical, 2. Take a look with 3. We would have 3, because it's a 45, 45, 90 triangle. And then the third side would be, it's an isosceles triangle. I can't use the reasoning of 45, 45, 90 triangle. It's an isosceles triangle, so we know that these two legs are congruent. And then the third side would be 3 squared plus 3 squared equals C squared. So 9 plus 9 is 18. 18 would equal C squared. If we take the square root, this is 3 radical 2 equals C. 3 radical 2. So what do we notice? What's the pattern? When the side length was 1, we got 1 radical 2. When the side lengths of the legs were 2, we got 2 radical 2 for the hypotenuse. And when the side lengths of the leg were 3, we got 3 radical 2. Well, turns out that all 45, 45, 90 triangles where both legs are congruent and the length of the hypotenuse is square root of 2 of that leg. So it's L, L, L radical 2. This works for all 45, 45, 90 triangles. So if we know the length of one leg, we know that the other leg would be the same, and then the hypotenuse would be that length times radical 2. Remember, this ratio of sides only works for 45, 45, 90 triangles. So right isosceles triangles. So let's take a look at an example. Find the value of x. Give your answer in simplest radical form. Well, since we know that this is a 45, 45, 90 triangle because we have a right angle and one 45 degree, so by deductive reasoning, we can deduce that this angle is 45 degrees. So since it's a 45, 45, 90 triangle, and 8 is a leg and x is a hypotenuse, we know that x is going to be 8 radical 2. Since it goes L, L, L radical 2, and since L is 8, this length is going to be 8 radical 2. Now we're given the hypotenuse is 5. So how can we figure out the value of x? So if we're given that the hypotenuse is 5, how do we figure out that what the length of the legs are? So we know that the ratio of sides are L, L, L radical 2. So basically, we need to set up the equation that 5 is equal to L radical 2. Or 5 is equal to x radical 2. L or x doesn't really matter. And so when we divide by radical 2 on both sides, we get 5 radical 2 equals x. But what's wrong with this fraction? There's a radical in the denominator, making it irrational. So what we'll need to do is rationalize the denominator. So we're going to multiply. We're going to multiply by a special form of 1, which would be the square root of 2 over the square root of 2, so that we get 5 radical 2 over 2. So x would be 5 radical 2 over 2 and 5 radical 2 over 2, with the hypotenuse being 5. If you wanted to check your work, you could do 5 radical 2 squared plus 5 radical 2 squared equals 25, or 5 squared. The other type of special right triangle is 30, 60, 90 triangles. So in a 30, 60, 90 triangle, the length of the hypotenuse is 2 times the length of the shorter leg, and the length of the longer leg is the length of the shorter leg times radical 3. So across from the 30-degree angle is the shortest leg. We call it S. Across from the 60-degree angle is the longest leg, and we call that S radical 3, because it's radical 3 times as long as S. And across from the right angle, the hypotenuse is 2S, or twice as long as the short leg. So S, S radical 3, 2S. If it helps you to remember to do 1, 2, 3, you can do 1S, 2S, S radical 3. Even though S radical 3 is smaller than 2S. So let's do some examples. Find the value of x and y. Give your answers in simplest radical form. Okay, so before we just learned the ratio of sides of 30, 60, 90 triangles, we would not be able to solve this because we would need 2 sides of a triangle to figure out the third. But since we know that it is a 30, 60, 90 triangle, and that the side lengths are S, S radical 3, and 2S, we know that 22 is equal to 2x. So we can say 22 is equal to 2x. We can solve for x, and we get that x is equal to 11. Since x is equal to 11, this length would be 11 radical 3. So x is 11, and y is radical 3. So that we have 11, 11 radical 3, 22. X, x radical 3, 2x. Now let's do this one, where 15 is the length of the longest leg. So we know that it's the longest leg because it's across from the 60-degree angle. So that means 15 is going to be equal to x radical 3, since x is the length of the short leg. So we can then divide radical 3 on both sides of the equation. So we get 15 over radical 3 equals x, but we have a radical in the denominator, so we'll need to rationalize the denominator by multiplying by a special form of 1, radical 3 over radical 3, and we end up with 5 radical 3. Or if I were to actually do it out, radical 3 over radical 3, then this becomes, I'm just going to write it over here, 15 radical 3 over 3, and 15 over 3 is 5. So we get 5 radical 3. So that's x. And then y. So y is going to be 2x because x is the short leg, and the hypotenuse in a 30, 60, 90 triangle is twice as long as the short leg. And since x is 5 radical 2, x is 5 radical 3. So 2 times 5 radical 3 would be 10 radical 3. So we have 5 radical 3, 15, and 10 radical 3. You can always check your work by doing 5 radical 3 squared plus 15 squared. Does that equal 10 radical 3 squared? Let's do another one. Find the perimeter of an equilateral triangle with a height of 30 centimeters. Okay, so when we're looking at the height, the height ends up being the altitude and the perpendicular bisector. So this creates two 30, 60, 90 triangles. So if we know that the height is 30, this is the length of the long leg. So we can say that 30 is equal to x radical 3. Then we can solve for x. So divide radical 3 on both sides, and then we'll rationalize the denominator, and we get 10 radical 3. So this part right here is 10 radical 3. But there's going to be 6 of these because this is just half of one side. So to get the full side, it would be 20 radical 3. But then there's 3 sides, so it would be 60 radical 3. You can also find y, which would be 20 radical 3, but we end up with 60 radical 3. So if this is 10 radical 3, this would be 20 radical 3. And same goes for this side, 10 radical 3, 20 radical 3. So if you add them all up, we would get that the perimeter P is equal to 60 radical 3. 60 rad 3. And that is it. We are done with Unit 8. Please attempt the online quiz, and I will see you guys soon. Have a good one. Bye-bye.